Everybody, and thanks for joining us on this webinar today. My name is Paul O'Neill, and I work at Intel. And we're here today to talk about the concept of data confidence fabrics with Project Alvarium. And I'm excited to have my friend Steve Todd from Dell, Matthew Yarger from IOTA with us today, safely from Texas, thank God. They'll introduce themselves in more detail in a couple of minutes, but I wanted to set some background here, first of all, as to why we're all together here. At Intel, I'm part of our confidential computing group, and confidential computing is a relatively new concept which in its most simplest terms protects data in use. There's lots of technologies that we have now that allow data to be protected at rest and in flight, but allowing data to be computed on in a confidential manner and thus preserving privacy in areas like the public cloud has opened up a lot of new possibilities with data, particularly in highly regulated industries. On the back of this, we're now starting to see enterprises allowing access to very sensitive data sets or pooling sensitive data sets together to gain better insights or to potentially monetize their data sets or even building privacy-preserving federated models for data collaboration. Machine learning and artificial intelligence will dominate the confidential computing space and will need more and more access to private and trusted data sets. And this word trust is very critical. Confidential computing can use attestation techniques to aid the evaluation of trust techniques through things like software attestation. But in many ways, this new paradigm is working with data sets that are coming from very trusted sources and has mechanisms to allow control over what can happen with these data sets. But as we start to think about computing at the edge and the overall cloudification of the edge, can we really have assurance on the source of data sets? What about privacy-preserving edge using confidential computing techniques, for example? The edge remains a hostile environment for data sources, and both Dell and Intel see huge demand for more and more compute closer to where the data is being created and consumed, driving a new wave of multifunction compute-hungry devices. Artificial intelligence is fundamentally becoming pervasive in all applications and shaping the future of entire industries. AI can turn data from a burden into an opportunity. At Intel, we feel artificial intelligence and AI will be the defining workloads of the next decade, driving disruption across the data-centric landscape. But like confidential computing in the cloud, AI and machine learning workloads at the edge need to be fed with data. But data is valuable only insofar as you can trust it. If you can't be confident about the origin or contents, then do you want to take a risk on it? That's a big problem for businesses eyeing the 5G future and developing strategies for monetizing data generated at the edge. Project Alvarium, formed under the Linux Foundation, aims to help organizations disrupt today's edge business model by quantifying the privacy, accuracy, and security of data flowing into the networks using trust fabrics, potentially allowing for a more intelligent edge, promoting incentivized collaboration. So that's the background and the reason why we're here today. I'd like to first of all introduce my two friends here. I'll turn to Steve first. Steve, perhaps you can introduce yourself to the audience and maybe provide some of your own background.
Thank you, Paul. Hi, everybody. My name is Steve Todd. I'm a fellow at Dell Technologies, and my title is Vice President of Data Innovation and Strategy in the Office of the CTO at Dell Technologies. And I think the data innovation piece is what we want to talk about today. And looking forward to starting with my background in trusted data delivery in the data center. And the three of us will talk about how we can take that experience of trustworthy data delivery and move it out onto the edge. So happy to be here today, guys. Matthew?
Hey, everyone. I'm Matthew Yarger. I am currently the head of mobility and automotive at the IOTA Foundation, and my background is also in data and data security, predominantly from the U.S. federal government, working in cybersecurity, cyber operations, and digital forensics. So I'm excited to talk about cybersecurity, the innovations in data, and how distributed ledger technologies like IOTA can have a part.
Fantastic. Great to have you guys today. Just a quick as we get going, I think, as I said in my intro, data-driven decision-making and incentivized data collaboration are on the rise. As I said, machine learning, I think, will dominate. Steve, trust in data sources has to be the right way forward to allow this incentivization paradigm to flourish, right?
Right, and if you think, Paul, about the background of our two companies in a data center context and trusted data sources inside a data center, right? So if you think about disk drives containing critical data, mission critical data, and as you move that data up towards application, the trust is just implicit because we created this stack of trusted Dell and Intel hardware and software. And so by the time the data flows over all of that, it's intrinsically trustworthy, right? So how can we take that data center trust and put it on the edge when there's just so many challenges in the edge ecosystem, right? If you talk about devices, IoT devices that haven't been vetted, the heterogeneity of vendors, different geographies, different policies as you cross those geographies. How is it possible for an application to look at a random piece of data and trust it, right? So I think a data confidence fabric is the answer, right? And we like to think about it as this metadata sidecar or a confidence sidecar where you gather information about the origin of the data and its journey before it arrives at an application destination. So that's really the context in which our discussion has started, Paul.
Great, and we can talk about some of the opportunities that can bring later in our talk here today. But Matthew, I think it's probably fair to say that IOTA is in the data-driven arena already, right? You're seeing the value, and in fact, silos is a bad word for IOTA. You're the ones that are smashing silos down, right?
Yeah, I think that's a good point to make about IOTA for sure. Is it's one of the key differentiators of us in this distributed ledger space. Is when we looked at everything, we looked at it really from the first principles of what's blockchain and the distributed ledger is supposed to do, and how can we make it as useful as possible and as impactful as possible. And what we saw is these aspects of immutability and confidence and consensus and everything. They aid to solving a lot of the problems that we see in data. And one of the things that blockchains are really good at as well is uniting these fragmented ecosystems. So when we designed our architecture, one of the things that was really core to it is this ability to do data or value, which separates us from most things in the space, and doing it with as distributed a system as possible, which is IoT. So getting these blockchain type capabilities as lightweight and efficient as possible so that you can start to embed them directly into processors, gateways, servers, cloud implications.
I would add, Matt, that your architecture is actually not implemented as a blockchain, but actually as a graph. Could you talk about that a little bit?
Yeah, of course. So one of the things to accomplish these data use cases is this aspect of scalability. So to get embedded in lightweight devices like that and to be able to bring all these benefits down into such a distributed system as what you see in the IoT and edge use cases, we had to fundamentally change the architecture from a blockchain to what is known as a DAG, or just directed acyclical graph. And this essentially is a collaborative consensus method where it takes every participant in the network and it allows them to participate and contribute equally. There is no hierarchy in the network. There is no like miner or staker or anything of that sort. Everybody that is involved in the network is contributing equally, whether it's a sensor or an edge device or a cloud implementation. And then the other aspect is you can't have fees if you're trying to move data. You have to be able to send 1,000 data transactions or packets for the utility of one valued transaction or packet. And so that really forced us to change the way that we looked at how to implement this appropriately so that it scale out to these systems as holistically as possible. And then one of the other key aspects is an IoT and edge for implementing these types of confidence and consensus and tamper resistance. You have to be able to do it in that lightweight fashion with no fees and in near real time. And the traditional blockchain model of the sequentially linked list of blocks spread over a distributed network with immutability and consensus, it's slow. It's not tailored to these types of edge use cases. So when we redesigned from first principles the blockchain capabilities with this DAG structure. Those are all core fundamentals that had to come into place to really scale out to IoT and edge use cases.
Yeah, makes sense.
Okay, so Steve, I just want to go back to our initial conversations and our initial sort of views of data confidence fabrics. We initially met on more talking about privacy at the edge, which brought us to this concept of data confidence fabrics. We together, both of our companies are working on very strong edge strategies. We both have are highly invested in edge. As I said earlier on, we see AI and confidence computing with machine learning, and et cetera, being defining workloads of both edge and cloud and the cloudification of the edge. We have built a white paper together with our view of what's happening around data confidence fabrics and privacy at the edge and how we can sort of build trust. And that white paper will be available on the via the webinar platform. I think you can download the link there. But as we said in our intro, there are a lot of interesting technologies that are being developed by our companies, with our root of trust base in silicon, trusted storage solutions, trusted HCI, data protection, and stuff like that. So a lot of these technologies that can fuel a data confidence fabric here. I think you may have a slide that you can maybe show us, showing that data flow and how data can flow through a data confidence fabric. So maybe an overview of that I think will be good for the audience, and then maybe how that flows into the connection with IOTA and how IOTA fuels all of this as well.
Sure. Well, Matt, if you could display our starting slide. Paul, you said it, right? We took our technologies in the data center and we strung them together to preserve privacy in the data center and privacy and trust for the application. What we're doing here, and if you look at the flow of data on the edge from left to right down at the bottom, we're just arranging Intel and Dell technologies down here on the bottom. And the goal is, as data flows from left to right, we're generating annotations and confidence metadata and storing them in some kind of distributed ledger, right? Like a sidecar that's tracking the origin and the trustworthiness of the data, so that in this case, right, the application can not only look at that raw bit stream, and you can also associate some sort of score with it. In this case, we just use addition. So if you look at how this looks dynamically, Matt, on the next slide, right, you can see this visualization of the data flowing from a sensor across different edge infrastructure, for example, trusted componentry from Intel and Dell. And Alvarium is just allowing the calculation of these confidence scores so that by the time the application receives the data, we've actually calculated a confidence score along with some history where the application or an auditor or somebody else could inspect the origin and the journey that this data made. And so Paul, as we discussed the possibility of this solution, we realized we needed a ledger partner, someone that had created this technology that can scale from sensor all the way up to the cloud. And we chose IOTA for a number of reasons that we can talk about.
Yeah, and I want to dwell on something you said there, Steve, which is super important in all of this. As we build trust in data, as they're coming from edge devices across heterogeneous networks, I mentioned in my intro things like highly regulated industries. And we know from even conversations with people in financial services, the whole concept of the ledger is critically important here for things like compliance, for example. How do we build compliance services on that? If something happens, how do we go back to those immutable records to make sure that what happened actually happened? So that word compliance is super important here as well. Matthew, Steve mentioned Tangle, right? Maybe you can give us an overview of what this Tangle ledger technology actually is, and then, IOTA streams, and maybe you can sort of stitch that together for us.
Okay. Do you want me to stop sharing this image and move on to the next one for it?
Yeah, let's use the next slide as a context for the explanation. I think it's a good visual.
Okay, perfect. Yeah, so IOTA has two aspects that really cater towards enabling the vision of data confidence, which Steve has been trying to put into motion for, I don't know, how many years now, Steve? Like 3?
Couple years, yep.
3 or 4. So Steve's really been foundational in like creating this vision and pushing it, and from the Dell perspective, and bringing us into the picture. And when we saw it, we said, okay, well, we understand exactly what's happening here. And there's one aspect of IOTA that is intrinsically different. If you look at the IOTA protocol, or the distributed ledger, it acts as a transfer mechanism. And it can act as a transfer mechanism for IoT and edge cases, which gives you a very high level of confidence in the metadata that you're getting and these confidence scores and structures. But the thing about the Tangle is it's inherently unordered. It's directed because it is a directed acyclical graph, but it's unordered. So you need a way to create structure over this unordered ledger. And one of our layer 2 capabilities, which is IOTA streams, gives the framework for how to do that, how to take implementations from a sensor or gateway or a server or what have you, and start to structure that out in channels so that all these data, this metadata coming from each of these different devices can go over the Tangle, and the application can essentially subscribe or understand how to find that data in a very privacy preserving way. So one of the other aspects about us is we are based in Berlin, so we're very adherent to GDPR, and we design every solution, whether it's in Europe or outside of Europe, in a GDPR perspective. So when we went through this process with Steve and Dell, we also did that. We said, how do we start to implement directly onto these gateway servers and what have you? How do we take streams and structure out this metadata, which is what Alvarium's done in a lot of different ways. And then how do we make that accessible as quickly and efficiently as possible? And that's what you're seeing come together in this graphic, is instead of like the previous one where you have it coming through and the scores are getting appended to the ledger at the end. In this one, the scores are actually coming from every device individually and going directly over this network. So there's no single point of failure for the data to get out. And it also gives you a stronger operational perspective of what's going on with your data, where the issues might be coming from, and what have you. So do you want me to show the next one as well, Steve?
Yeah, just this one right here.
Before you go to the next one, just a little segue. Matt, if you don't mind, you mentioned privacy there, for example. Mm-hmm. Perhaps maybe an example of where privacy is important for IOTA customers. I know you work across many verticals, and I talked about highly regulated industries in my intro. Have you got examples of where privacy is really important in sort of IOTA deployments, if we can use that word?
Yeah, so we have a lot of different areas that we're working that privacy is really the highlight of what's at the core of what we're trying to create. Some examples can come from sectors like climate data, where you want to have this availability of climate data, but you don't want a single source to own it because it needs to be in a way that's inspires confidence at a system level. And so taking climate data and putting it over this network and allowing the ownership to happen at a facility level or an organizational level or what have you, and giving oversight into that process holistically, allows you to create a more privacy-centric system, and it allows organizations to give access to the data that is important for compliance in climate data or greenhouse gas emissions or anything like that, and actually take that and make it visible to the necessary parties without everybody necessarily being able to see it. But it is there, it's visible, but it's encrypted, it's privatized, it's segmented and compartmentalized. So it's protected all the way from the source of where that data is pushed onto the Tangle, and then all the way from where it's pulled off. So that's one of the key aspects from my cybersecurity background that I found really appealing, is you're not getting it at the cloud like you are with a lot of other ledgers. You're able to secure that data and add tamper resistance to it and add trust to it all the way from where it's being produced, whether that's on a sensor or a gateway or what have you.
And as you said, Matt, then you have permissioned access to some of that data. And it goes back then to understanding that that permissioned access leads to things like, as we said earlier, compliance and stuff like that. So that requirement is a definitive requirement for these type of deployments. It's not a nice to have, it's a must to have, right?
Exactly.
Okay.
Yeah, and the point I was making, Paul and Matt, is that the demo that you're going to show in a few minutes, Dell simulated and wrote some data confidence fabric code at this bottom layer, right? So Paul, here we have it, right? We have Intel and Dell products put together in a stack that spreads across an edge ecosystem. And as the data visits every trusted element of that stack, for example, maybe the data is processed inside an Intel secure enclave. We annotate and we score that in a simulated way. And then it flows into a Dell storage system where it's perhaps assigned a cryptographic hash. We annotate and score that, and we use the tangle in a parallelized way. And perhaps, Matthew, you can move to the next slide and show that this simulated demo that we did changes the picture significantly.
Mm-hmm. Yeah, very good. I mean, it's like the meeting of trust at the edge with the cloudification of the edge and confidential computing is like turning all the lights on for me. That's my desire at the end of the day. Maybe, Matt, we should see the demo at this point. I think, maybe this is the first ever industry display of data confidence scores using a data confidence fabric. So good luck with the demo, Matt. We'll have our fingers crossed here.
All right, let me switch my screens. And share this one. Okay, can you see that one?
Yes.
All right. It's about 3.5 minutes. But here we have the initial interface for creating data confidence implementations with Alvarium. What you see on the right is what's happening in the backend. So it's essentially connecting to the APIs, setting everything up. And on the left side is the interface where you can see you come in here and you give the sensor an ID because we want to start all the way at the edge to where the sensor is. You add the sensor to the Alvarium implementation and goes through this process. It takes a little bit.
And essentially can be any sensors we're talking about here, Matt, in any edge device, effectively, any low-powered edge device, and anything that's out in the wild.
Yeah, exactly. So now it's spawning the annotator, and you'll start to see it come up here in a second. But essentially the way this happens, it can occur in a zero-touch model as well, to where you can deploy Alvarium onto existing infrastructure. That's the intent or the long-term vision of what we'd like to accomplish. So if you have an operational capability, you can take a configuration file of a sensor or gateway or what have you and add this capability to it. You don't have to necessarily create something from scratch. It's made to be interoperable and flexible so that you can come through. And in this instance, we're doing sensors. But if you have a configuration file that you want to update for a gateway or an edge server or what have you, the ultimate goal is to take this capability and allow it to be remotely deployed into that and then use the capabilities of the existing hardware as efficiently as possible. And
so conceptually deploy fields of IoT devices.
Exactly, because it has to be as easy and scalable as possible. And if you have to go through and do it individually on every piece of hardware, then that's going to take forever. But if we can do it in this remote deployment mechanism, and then it can use the capabilities that are intrinsic on that system, then that allows the organizations to have a stronger say in how they're deploying their data confidence fabrics and what it looks like. So here you can see the confidence scores are coming in. We have multiple sensors that are annotating different things like policy, boot, storage. And as these different processes on these sensors are getting annotated, it's changing the confidence score. You'll see there's ownership.
We can see those confidence scores changing there, Matt. Is that what we're seeing on the left-hand side?
Yeah, you can see the confidence scores changing on the left-hand side. Okay. And depending on which processes each system is going through, like we had showed in that initial slide, If it has the capability to go through and have a secure boot, or it has encrypted storage, or it has SGX and confidential compute capabilities built in, then those are all things that we think with Dell and Intel hardware specifically bridge every industry. And that's very important to say, like, what is the baseline for creating confidence, and what does that look like? What does that process look like? And then from that point, where do we go from there? Because it's going to change.
And it may be the case that, you know, there are devices out there that can't have Dell and Intel inside them, that can't have SGX inside them. But again, you know, techniques like attestation of low power devices and how they boot and all that sort of stuff, they're all the variables that get swept into a data confidence fabric. The configurability of a data confidence fabric is critical because it can be, I suppose, changed. It's malleable to all devices, I guess, right?
Exactly, yeah. We need it to be as agnostic as possible so that it can go through and actually scale out to more than just Dell and Intel devices. Because if it's going to unite industries and connect fragmented ecosystems, it has to be able to do that at scale.
So I would say, Matthew, one of the things we noticed while you were running the demo, right, is confidence scores were rising. Mm-hmm. And we had some annotations in there that were just generic, like ownership of data has been established, a policy for the data has been assigned. We have one final slide, which really is a call for industry collaboration. If you could put that slide up, and we could talk about, you know, once we wrap up, Paul, this is really where we want to get to, right? Here's an example of the energy industry. What would the trust metadata look like? What would the confidence scores look like? How do you calculate the confidence scores? Now that we have this framework that works across all verticals and different industries, we're looking for partners that we can take the simulation and build a real world example, right, Paul?
That's right. So, I mean, that's the key thing here. I mean, as you look at data confidence fabrics, how does it affect your industry? We mentioned a few times highly regulated industries, for example. Here we feel that, you know, data confidence fabric can it lead to things like compliance as a service? How does that help you recover from issues that may have happened in your industry, whether it's backtracking through tons of records to figure out whether, you know, what was breached where, or you know, some other hack or some attack on some IoT devices, et cetera, et cetera. You know, that's critical, and that's potentially hugely cost saving. But at the end of the day, you know, having a confidence score on data allows you to make a data-driven decision on what you want to do with that data. And as we said in our intro here, AI and machine learning are going to drive, you know, a lot of these workloads in the next 10, 15 years or whatever. Data owners have to get to the point where they're confident to do things with data, or not confident to do things with data. We talk to a lot of data owners in the IoT space, and they're sitting on tons and tons and tons of data that they don't know what to do with, and they can't do anything because that data doesn't have provenance. One question I would ask both of you guys is that, you know, as machine learning gets its hands on data, is it fair to say that, or data that's driven by a data confidence fabric, is it fair to say that decisions can be made based on the score of that data, but the score of that data is preserved once it's merged or aggregated with other data, that, if you will, the watermark is preserved? Is that too much, guys, or does that seem like the right thing?
No, I think one of the reasons for Alvarium being a community effort, right, is to try and standardize scoring and or annotations so that they can be well understood by these models and integrated into the AI ML logic, right? So we talk about data being on one channel and then the confidence scores being on a sidecar. But in the end, both of those will be brought together by applications to analyze together, and the logic will change, right? The decision that business logic makes will change based on confidence level. So that is the vision, Paul.
Yeah, I think it's a good vision. Matt, anything to add to that from an IOTA perspective?
Yeah, I think there's a few things you highlighted there, but that's one of the reasons that we were really excited to come and work with Dell on Alvarium as well, is this intent for open sourcing and bringing a community around data, because we think data is something we all understand. It is the lifeblood of technology and communication systems or connected systems, but it's still so amorphous around, like, what is it? How do we standardize it? How do we enable trust in it? And how do we start to create a better system down at the root of where data is created? And I think things like embedded machine learning and everything y'all are doing in that space have a lot to say. And IOTA has this perspective of creating a machine economy. Like there's this future that we all understand, but the how is really difficult around how do we enable the devices that are connected around us to interact with each other, to do the things that make our lives easier, but in a way that we know can't be manipulated or can't be abused. So having this inherent level of trust and confidence that can be granular at this scale and implemented into things like confidential compute frameworks and secure enclaves, embedded machine learning, and like federated learning models, we think is absolutely core to enabling that future of like AI and automation with the machine economy. And that's something we've had as our vision since the very beginning.
Yeah, I would agree that certainly the federated model seems to be very applicable here. So Matt, what would you say? There may be people listening to this call who are sitting on, petabytes of IoT data that maybe they have customers who are saying to them, hey, help me monetize my data. Help me get to a point where I can share my data with that organization over there in a trusted way across heterogeneous networks. Is IOTA open for business to help these type of companies?
Yeah, absolutely. I mean, that's one of the things we do really well is we connect these fragmented ecosystems. So this entire understanding of confidence fabrics and creating a connected fabric between devices, organizations, different stakeholders is really at the core of how we operate. So we don't typically do projects that are just us and one other organization. We find ways to say, okay, what is your problem? How do we address it? And how do we start to make your data as useful as possible while still having privacy-centric designs and scalability and everything at the core of how that happens? And one of the interesting things is once you're taking things like streams and you're starting to structure data all the way at the edge, and you're putting it over this distributed and decentralized system that is the Tangle, then the sharing aspect of data becomes so much simpler than what we're currently seeing in the industry. Like you don't have to download major data sets and save them in zip files or what have you, and then send them across and then have them do their own processing and wonder, is this the correct data or not the correct data? You can give them access to the data that they need directly from the source without giving them access to the source. And that capability from a security perspective and from a confidence perspective and from just creating trust in the system is so pivotal to what we think the future of IoT and edge and data confidence and AI and everything really need to be built on top of.
Yeah. Well said. And I think, Steve, when we look at our customers, they really want to monetize data at the end of the day, right? It's really about how can I make, as I said, how do I get to the point where, I'm afraid of the data into give me more data so I can monetize it. I think that's one of certainly both of our company's strategies, right?
Right, and at the very beginning, you said it, right? There's too much risk right now on the edge. And so, this is the low-hanging fruit, right? We reduce risk with the data confidence fabric technique. And that, one of the main ways we reduce risk is you pass your audit now. Right, you have this immutable audit log that's searchable, and you can answer any audit that comes your way. And then once you've focused on that and that's working, now you have all this rich metadata that allows you to monetize it. Right, so compliance comes first, and then monetization follows. So reduce your risk, and that's going to open up your business opportunities.
Yeah, totally agree. We've got 5 minutes left, guys. So a couple of things I want to cover in those 5 minutes. Steve, you mentioned open standards. This really is an area where it will be difficult to get a complete grab unless there's a standardization process here or a way that others can join in on this. What's your view on standards generally in this space? I mean, where do you see or how do you see that being achieved even?
Well, from the very beginning, we knew that the heterogeneity of the edge, right, the different vendors, the different policies, the different verticals, was so complex that no one company or no set of 2 or 3 companies could solve this problem, right? That we had to go to the industry with the idea and just show that it could work, and then let the community come together and define confidence scores, different types of metadata on a per vertical basis, right? So there's, we approached the Linux Foundation, we looked at the LF Edge initiative and said that's the logical place for this work to flourish, right? And you can see already that the 3 of us have come together, and now we're looking to grow the number of people that want to advance the technology.
And that same, I guess, in your area, I mean, IOTA is very standards focused, I would imagine, and I guess you would agree with Steve on the need for grabbing standards together to drive this whole paradigm, right?
Yeah, absolutely. So, I mean, IOTA took some really interesting steps with trying new innovations in the space early on. But in our evolution as a technology, we've very much become as involved in the standard space as possible. So even streams has been submitted for standardization as a response for an RFP to the object management group. So we're going through the process to standardize what these channels and these frameworks look like to structure this data over a decentralized network like the Tangle. And we're constantly working with other standards bodies like OSI and a number of others in the space like IEEE, SAE, and different industry verticals as well to understand what standards are key to their industry, and then how do we take those standards and start to digitize them in a more decentralized and privacy-centric fashion, or build on top of them with new capabilities.
Okay, so I think contacting IOTA is recommended probably in for a lot of people who are interested in doing this. Matt, what's the best way to get in touch with IOTA on the back of this?
The best way is we can put our email information here in the bottom of the webinar. You can always reach out to me. I'm very active on Twitter as well if you want to just have a conversation that way or over social. I'm at MAT_YARGER. And we can start to have these conversations around how do we start to standardize this with the Dell and Intel and the other parties that come into the space.
Okay, and we can publish details, I think, contact details, etc., at the back of the webinar. Okay, I want to wrap up. I think we've got about 2 minutes left. Steve, closing thoughts from you on sort of, what are we looking for? What do we want? Closing thoughts in a 1 minute sort of scenario.
Thanks, Paul. Thanks, Matt. What we're looking for is those use cases where trust on the edge and reduction of risk is critical, right, to the lifeblood of any organization. So if someone from the industry has joined this webinar to learn a little bit more and thinks it might be the right fit for them, we would love to take this simulation that we built and deploy it in a real world environment. So let's start moving towards that end, to building the data confidence fabric technology for real in the industry.
Hurrah. Matt, closing thoughts from you before I wrap?
Yeah, I think this is a really strong core to what the industry needs to start to understand data confidence and granularity and how to do that from where it's created all the way to where it's consumed at the application. But just scaling this out as the next steps is really pivotal to making sure that this provides the impact that it has the potential to do, and getting it into different IoT and edge labs like what Dell and Intel and others have, and testing it with real data and real world scenarios is where we start to have the confidence in the system and say, yes, this works. And yes, this is how we progress this technology as an industry or as a data-driven industry, whether it's in mobility, like where I work a lot of times, or in smart cities, climate, or what have you. This is something that can unify those systems and bring a way to have that level of collaboration while still protecting business logic and still protecting your intellectual property and everything like that, and can do it in a very human-centric or organizational-centric way. And understanding that and experimenting that is the first step to really making the progress that we need as an industry. So we're very excited to see how that happens.
Yeah, very good, Matt. And I think a good point there on protecting intellectual property. Closing thoughts from me I want to repeat that Edge is still a very hostile environment when we're working with data sets. Both of our big giant companies are conscious of that and working with that. Partners like IOTA are going to be critical in helping us to achieve that. We can't do that on our own. As we drive compute to the edge, that compute is going to be hungry, super hungry. We'll have a lot of this multi-function computation at the edge. As we've said a couple of times, we know that AI and machine learning is going to be fundamental and pervasive in all applications, shaping the futures of all the industries we talked about today: finance, industry, industrial, even healthcare, et cetera, et cetera. We want to get to a point where your data is not a burden, it's an opportunity. And working on that opportunity, potentially monetizing at that opportunity, is really what we're trying to bring here with a data confidence fabric. If you can't be confident about the origin of data, you can't trust it, you can't do anything with it. So I would encourage people to have a look at data confidence fabrics, open communication with us. If there's something that we can work together, fantastic. For now, we'll open up to Q&A, and Matt, Steve, and myself happy to answer any questions that come across in the chat window.
Okay. Okay. Okay, so this is Paul again. We have a lot of very, very interesting questions from the audience. A couple of just quick housekeeping things. The replay will be available to download, and perhaps we'll send a link out as part of the audience announcement here. The contact details for getting in touch, particularly with IOTA, etc., we'll also make an announcement from the audience to the audience on that as well. So no sweat, you'll get all those sort of information. There's a bunch of questions. I'm going to try and bunch them up, but there's a couple I really like actually that I can get Matt's and Steve's creative thoughts going. One was quite interesting. Somebody asked about an example application that they're developing a portable battery pack with its own secure element and an IOTA wallet. Each battery pack will obviously be swapped in and out of lots of different UTVs that their own secure elements, IOTA wallets. How can we ensure that transaction edge data, use data is secured through this fabric? Is it possible? I'll go to you first, Matt.
Yeah, I think there's a few different ways that you can address this. So first off, it's great to know that you're implementing an IOTA wallet into your portable battery pack. There's a few different things you can do to add in the Alvarium type capabilities. I think integrating the SDK and some of the baseline IOTA frameworks, such as streams and potentially identity, would be very well aligned to what you're doing. And as we come out and push this out into Linux and build it out as well, there should be a lot of focus on integrating this into those types of hardware. So we're already working with a number of other, or communicating with a number of other hardware manufacturers as well that could potentially be well suited for helping solve that.
Cool. Steve, there's a few questions that bundled up around where we see industries that could benefit from a data confidence fabric. I think, as we said throughout the webinar, we've sort of mentioned industries like finance and others where compliance is necessary, or higher levels of privacy is necessary. What's your view on the industries that we should walk into with data confidence fabrics?
Well, industrial IoT is a big one, right? There's a hesitancy to release some of the data coming from that environment out into the world. And by first logging it and measuring it with Alvarium, you got a great start, right? Medical use cases or any other use cases where privacy is critical are a good example. And, you know, one of the questions, Paul, that I really liked was, what's innovative here that melds verticals together? And the answer is, what's innovative is this is the first framework that can measure trust no matter what the vertical, right? So the same framework can be applied. It's just what are the annotations and what are the different ways to calculate confidence that's based on that vertical. So that's really the innovation, I think, that ties together and allows us to operate in multiple verticals.
Right. So the concept of a data confidence fabric being a bridge from one vertical to the other. Think of machine learning taking data from two verticals. You know, I think that's pretty powerful from a trust perspective. Matt, maybe you take a stab at this one. How might Project Alvarium help to improve electronic voting data security and also make it possible to audit and prove with full confidence that the data has not been manipulated? Interested in your answer to that from an Intel perspective. You know, we've done a lot of work with secure enclaves in voting machines, et cetera, as well. But as voting machines push out towards the edge a little bit more in countries, different countries around the world, it's an interesting question. Any ideas how you would think about tying them together?
Oh yeah, definitely. I mean, this is a topic that I'm very interested in because, you know, there's a lot of relevance here in the U.S. around it and in other areas too, of course. And we discussed things with the Open Source Election Technology Foundation and a number of others in this space, and I have a draft paper that eventually I'd like to publish on it. But there's a lot of different things that come into play with that. From a U.S. perspective, there's the regulatory requirements from states and cities to control their own infrastructure when it comes to voting systems. So one of the things from the IOTA perspective that's really key for that is this data sharding concept that we're working towards and enabling essentially ad hoc data shards for regions or locations to be implemented into those type of processes, and then having the Alvarium confidence fabric capabilities built into that can give you that root of trust in the vote, and then using these like tokenized or data packetized capabilities that are native to the Tangle also give you a lot of functionality there. So I think with what we all bring to the table here with SGX and confidential compute, the hardware that Dell brings to the table, Alvarium, data confidence fabrics, and these decentralized data concepts at IOTA, that's very much a solvable problem. But we have to start building towards that, and that could be a very good use case for piloting out an instance of Alvarium moving forward.
And really for global good here as well, Matt, right? So exactly. We're not talking about the European Union or the United States. We're talking about other countries, you know, that may not have the infrastructure that we have, that we're lucky enough to have, I think. And that's where I think the global reach of IOTA can really help here.
Yeah, very much so. So you would just standardize that framework in a way that is agnostic to the process so that you can scale it into other regions very easily. Yep.
Another good question I liked as well, you know, and I'll kind of group a few together here. A lot of the nodes that you know we would be working with are frequently disconnected from the internet, right? How can you know, IOTA or Alvarium deal with this and sort of, you know, maybe react to something that hasn't been up in a few days or reach consensus based on that, and when an amount of data is collected and stored, et cetera, et cetera. Have you thought through that, Matt, in a practical sense?
Can you repeat that question? Sorry, you broke up.
So basically, when we have sensors, et cetera, that are disconnected from the internet on a frequent basis, right? How do we deal with devices that are up after a few days and reach consensus when an amount of data is collected and stored?
Yeah, so there's a few different aspects of that, and this is something that we went through a discovery process with old collaborations like what we had with UNOPS and others. because scaling this out to like developing nations or high impact use cases around natural disasters or things of that nature is really important to the impact that we want to make as a foundation. But because of the way we've structured out our nodes and because they're so lightweight and efficient, essentially you would have a queuing mechanism built in. And the big aspect of having these lightweight nodes is they don't need to store everything always. We have this belief that data has a half-life. When you're at the edge in an IoT spectrum, you don't need to know data that's 3 years old or anything like that. You just need to know the data that's relevant to you as a device or an organization or user. So the ability to synchronize a node quickly based on the amount of storage and processing power and bandwidth it has available is very key to how to do that properly. And then the ability to queue those transactions so that once the synchronization is complete, they can be pushed out onto the network as quickly and efficiently as possible is also the other piece.
Okay. Steve, a couple of questions around, what are the key alternative approaches to ensuring confidence in data collected that significantly diverges from the data confidence fabric approach, and why? I'll sort of open that up by, in our intro, we talked a lot about, organization of data and trusted data in the cloud perspective, and there are sort of solutions, but, confidential computing being one of those. But what's your view on sort of alternative approaches and maybe framing that as to why, a data confidence fabric may be unique in that sense?
I would say that one thing that's happening, given the absence of data confidence fabric technology, is you're seeing some single vendor stacks that go right from the sensor up to a cloud, right? And so that's something that's being built today, right? And heavy investment is being made in a security aspect, right? And trying to prevent people from breaking into that single vendor stack or, handling failures in that single vendor stack. And while that may work, the problem is, portability over time, right? If I want to take that data and move it into another stack, I don't have a history of the confidence or lineage or any of this trust scoring or measurement that we're trying to standardize here. So I think, lacking this technology, people are looking for an easy button that is a secure path. And in the short term, that allows you to get things up and running, but in the longer term, it could lock you in and cause some costs down the road. Okay.
Matt and Steve, there's a few questions around POCs, right? Are we doing POCs at the moment? The answer is tentatively, but one of the real call to actions here is, hey, how can we work with people to drive POCs? In fact, Matt, there's a nice invitation to go to the Cambrian Mountains in mid-Wales, which I can assure you is a beautiful place just across the water from me here in Dublin. So maybe that's you should take that offer up. But I guess the point is, IOTA's open to looking at least the feasibility of certain POCs with a data confidence fabric, and how would you like to approach that?
Mm-hmm. Yeah, there's a few ways, and that's really what the intent of all of us being here today is I think at this point we've got the MVP, we've done the POC with it, with the simulation data that we've enabled in the demo, and the next step is really taking it into those real world pilots. So how do we build it into different types of hardware from different types of providers, show this interoperability, show that it can be an agnostic framework, and then find the right industries and use cases to really scale it out. Because as you and Steve has referenced, we know the baseline for security of how to ensure your hardware and everything has that baseline of confidence, whether it's secure boot, SGX, etc. But scaling out to those industry standards and those pilots is really pivotal to this making the impact and growing to the degree that it needs to. So we're open to that from the IOTA side always. We're very active in a lot of different collaborations and a lot of different frameworks, and we would love to continue to progress this technology with Dell and Intel so that we can pilot it in different areas and different industries. So.
And would you see, it taking much time for the modern sensor device or whatever edge device or node device it is to be upgraded to take or make use of Alvarium? Is that something you see as fairly or going to be relatively straightforward?
Yeah, and that's the aim from our side, because we are building out the underlying functionalities of Alvarium with the IOTA perspective to be general embedded. So we want them to be as lightweight and efficient as possible so they can scale into different types of hardware. We've tested them in a lot of different types of hardware already. We have other relationships with other hardware manufacturers like ST Microelectronics, and they've integrated them into microprocessors and a number of other capabilities. And I think there's short-term solutions of saying what needs to happen on the sensor and what could actually just happen on the gateway. And then the long-term solution of all these different sensors that are out in the market having this capability or being able to implement this capability is really the end goal of how this can make the biggest impact.
Okay. Very quick one for you, Matt. Give you 30 seconds to answer this one. Are you envisaging that data confidence fabrics be running on the IOTA main tangle, or are you thinking of implementing some use cases on private tangles? Good question.
I think private tangles is a way to test it from a pilot standpoint, but it's very capable of operating on the main tangle. And then as we do data sharding, it's essentially going to allow for contextually defined networking in a decentralized manner. So the different industries and localities that Alvarium is operating in, when using the IOTA aspects, will have a contextual and locality-based capability. So they'll be able to operate on a data shard but still relate to the main tangle.
Okay, so needs basis, whether it's on the main or private tangle. One question I'll take a stab at answering. In our white paper, we discussed the loss of social trust and need to restore a sense of distributed trust. Is data confidence fabrics a way of scoring in this area? The answer is yes. I think even the need for digital media integrity, fake digital media, a lot of our big customers at Intel and Dell have a lot of problems these days with media trust. Is data confidence fabric something that fits into the media vertical? Yes, possibly. I think even trust in what's published on the internet. There's a couple of very interesting projects in that area as well that I think potentially overlap a data confidence fabric, or at least feed variables into a data confidence fabric, WordPress and stuff like that. So we will certainly look at that. A bit more of a technical question. Will this or could this affect the time of the data getting to the application driven by the multiple steps? Will it not introduce breakpoints into the process? Is it simply driven by privacy compliance? Steve, you want to take a stab at that?
Sure. I think that the picture that we showed during the presentation has a separate data path, right? And we talk about the IOTA tangle as a sidecar where the annotations, occur. And those annotations can happen in an asynchronous manner, right? So the data can fly through, and there's one simple call made to the tangle, right, to update some Alvarium metadata, and off the data goes, right? So it's not necessary to pause or interrupt or in any way interfere with the flow of data. This is meant to ride seamlessly on top of it.
Okay. So one more, I think. People asking about, can this control GDPR, etc. I think what we're saying with a data confidence fabric, I don't think it can control GDPR, but it certainly can get to a point where you can prove compliance or potentially compliance with GDPR. And we mentioned things like compliance as a service, for example, is potential here to go back through an immutable record and show people where data came from, who generated it, when it was generated, et cetera, et cetera. So I certainly think it can lead into that. Steve, do you want to augment on that in 20 seconds?
I missed it, Paul. I missed the question.
That's okay. It's we were talking about GDPR, et cetera, so yeah, no worries.
No, we've designed, and IOTA was certainly designed in Europe for GDPR, and so that strictness applies globally now, right? If we're using that technique.
Yeah. Yeah. So I think the answer to that is it can certainly be a very, very powerful tool in proving that you're compliant to GDPR, and that's really the genesis of what we're doing here. Okay, I think we're out of time. As I said at the top of this, the contact details will be available and a replay will be available. And I'd like to thank everybody, no matter where you are in the world, for your time, and thanks for listening today.